Welcome to the Explainer. Today, we are tackling a seriously massive topic, but we're going to do it in the simplest way possible. We're answering two huge questions. What is AI, and how exactly does it work? We are stripping away all the confusing jargon to figure out exactly how artificial intelligence processes information under the hood. So if you've ever felt completely overwhelmed by all the tech speak, you are absolutely in the right place. Okay, let's just dive right into our 5-step roadmap. We're going to cover 1. The Hollywood AI myth. 2. How AI actually works. 3. The black box and bias. 4. Types of modern AI. And 5. Real risks versus sci-fi. So, starting us off with Section 1, the Hollywood AI myth, Terminator versus reality. You know, most of us first learned about AI from 90s movies like The Terminator or The Matrix, right? We pictured these villainous, highly conscious machines taking over the world. And honestly, it was completely natural to feel a little uneasy. But instead of destroying humanity, AI just quietly became a part of everyday, serious decisions. It's actually dictating your YouTube and Instagram feeds right now. It's working behind the scenes in banks to approve loans, calculating your insurance premiums, making massive stock market trades, and even helping doctors diagnose medical conditions. It is literally everywhere, but it certainly isn't the evil cinematic villain we all expected. Which brings us right to Section 2. How AI actually works, stripping away the jargon. To really understand why a tool like ChatGPT seems so incredibly human when it actually isn't, we have to look at how AI truly operates at its core. And there is a massive difference between the computers we're used to and artificial intelligence. Regular, traditional computers, they're essentially just super fast calculators. They just do fast math based on extremely rigid instructions or programs that a human explicitly gave them. If they encounter something outside those instructions, they just fail. But AI learns from data to identify new patterns entirely on its own, without needing specific programming for every single little scenario. It basically figures out how to do something new. Now, what's super interesting here is how AI actually learns those patterns. Imagine we want an AI to recognize a bird. Instead of writing a rigid rule book, we give it a mathematical checklist. The AI identifies objects by assigning percentage weights to specific features. For example, it might assign 20% importance to having 2 legs, 30% to wings, 30% to feathers, and another 20% to having a beak. If it looks at a crow, it hits 100% and says, yep, for sure, that's a bird. But what happens when we show it a penguin? Well, a penguin's wings kind of look like arms, and its feathers definitely aren't standard. The AI might only score it a 40% and guess, not a bird. And this right here is the absolute crucial moment of training. When the AI wrongly guesses a penguin isn't a bird, a human steps in and corrects that error. The AI takes that feedback and automatically adjusts its internal weightages. It learns that, hey, maybe visible feathers aren't a strict requirement, and hitting 100% isn't always necessary. It tinkers with its own internal math so it can be smarter the next time. So the biggest takeaway here is that AI doesn't actually understand what it's looking at. It has no mind whatsoever. It is simply calculating numbers and weight values to perform one very narrow, highly trained task. It also needs a massive, and I mean massive, amount of data and human correction to even get to a usable state. Plus, an AI trained to spot a bird can literally only spot birds. If you want it to identify a dog, you'd have to build a completely new program from scratch. Now, you might be wondering if this whole concept existed back in the 90s. Why is AI only blowing up right now? Well, we only have this technology today because of a gigantic surge in computing power. Computers today are thousands of times faster, combined with the endless training data that we all freely provide. When you tag a photo of your dog on Facebook or use the latest slang on Twitter, you are literally feeding the algorithms the massive datasets they desperately need to learn natural human language and visual patterns. All right, let's move into Section 3, the black box and bias. This is about what happens when automated training goes wrong. Because all this training happens automatically on such a massive scale, it inevitably leads to some really fascinating blind spots. Take this question, for example. Why did a highly trained, normally very accurate image recognition AI suddenly start misclassifying standard photos of pet dogs as wolves? The answer to that is something called the black box problem. You see, because the AI trains itself automatically, the system changes so extensively that eventually even its own creators can't track its internal logic anymore. In the case of those wolves, researchers eventually realized the AI wasn't even looking at the animals. It had noticed that in all its training data, the wolf photos had snow in the background, so it simply learned to look for snowy backgrounds instead of the physical features of a wolf. The actual logic it was using was completely hidden away in a black box.
And this brings up a major risk when it comes to bias. Because AI blindly learns from historical data, it naturally absorbs the flaws in that data. For instance, an AI used by a major company for shortlisting job interviews once universally rejected female candidates. Why on earth would it do that? Because the historical company data it learned from had a huge statistical bias toward hiring men. The AI simply mathematically assumed male was a necessary feature for a good employee. It's pretty simple. If the underlying data isn't perfectly neutral, the AI's output won't be either.
Okay, on to Section 4, Types of Modern AI. From text generation to deepfakes. Now that we know how it learns, assigns weights, and occasionally makes some pretty big mistakes, let's actually categorize the tools we're interacting with today. The absolute biggest buzzword right now is generative AI. These are systems that create completely new content that has literally never existed before. By studying millions of texts or paintings, systems like ChatGPT or DALL-E can write a wholly original novel or paint a completely fresh picture just from a simple prompt you type in. It is basically creating the new from the patterns of the old. But beyond just generating text and images, we also have natural language processing. That's what powers Alexa and Siri to understand the messy, complicated way we humans actually speak. We have computer vision running things like Face ID and traffic cameras. We have emerging fields like explainable AI trying to solve that tricky black box problem we just talked about. And definitely more concerningly, we have deepfakes. What's wild about deepfakes is they often use competing AIs. One AI tries to create a fake video of, say, a politician, and a second AI tries to spot the flaws. They just compete back and forth until the video is so incredibly perfect, it's almost impossible for a human to tell it's synthetic. Which leads us to our final section, Section 5, Real Risks versus Sci-Fi. What does the future actually hold? With all this immense power, from generating hyper-realistic fake videos to diagnosing diseases, should we actually be afraid of these systems taking over? Let's take a look at the timeline. Right now, we only have what is called weak or narrow AI. Every single tool today, even ChatGPT, performs highly specific tasks. But experts are looking ahead to artificial general intelligence, or AGI. That would be a machine with a broad, human-like capability to adapt to any problem. Optimists say 20 years. Others say 50. Way beyond that is artificial superintelligence, an AI much smarter than humanity that could improve itself exponentially, an event often called the singularity. However, the absolute most crucial point here is that even if AI reaches that superintelligence level, experts argue it completely lacks consciousness. It doesn't actually have self-awareness or truly understand what it is. The desires for power, control, and domination, those are fundamentally human traits. An AI that's basically just processing massive matrices of numbers doesn't just wake up one day and suddenly decide it wants to rule the world. The reality is far less cinematic, but honestly, maybe more pressing. The true danger isn't the machine itself, it's humans misusing the machine. AI is a remarkably powerful tool for fraud. It can be used to subtly manipulate algorithms for massive political influence. We have to worry about highly accurate deepfakes ruining reputations and those hidden biases quietly discriminating against people in critical automated systems like loans or hiring. The real threat is just us, weaponizing a powerful new tool. So to wrap up our explainer today, I want to leave you with this final thought. People constantly worry about AI replacing them in the workforce, but history shows us that while technology definitely shifts jobs, it doesn't end work. The machines aren't coming to willfully steal your job. However, a person who knows how to use these AI tools efficiently, they just might outcompete you. The question really isn't how to stop AI, but rather, how will you learn to adapt to this incredible new world? Thank you so much for joining me on this explainer. I hope you feel a little more empowered and a whole lot less confused by the AI revolution.